System part one, we're going to talk about the functions of the digestive system. And what is the main function of the digestive system? To digest the food. Great. So what is digestion, right? Digestion comes into different parts, right? There is a mechanical processing, right? There is a chemical process to it, right? There is an absorptive process of it, right? So we're going to talk about these things. We're also going to talk about the different structures that we have, primary and secondary structures that we have as well. We're going to talk about how food travels through, and that's basically the process of the food traveling from all the way from the mouth all the way to the rectum is what process known as peristalsis. And we're going to actually explain the different mechanisms and controls that our digestive system has. So the first thing is, the terms. So ingestion, and what is ingestion? Ingestion is actually being able to do what? Put the food into your digestive tract, right? Means starting with the mouth. So the digestive system is just also known as an alimentary canal. An alimentary canal consists of the following. It's just a tube, right? That starts at the level of your mouth and ends at the level of your what? Anus, right? So from the top to the bottom. Now these things throughout the development of the human individual, right? Human development, then as we are getting to a pre-fetus, a pre-embryo to fetus, what happens is that this tube actually changes, right? And twists around. So this tube can just go like this, or it can move 360 degrees, or move 180, or move 60 degrees. And that's where you start making the stomach, the large intestine, the small intestines, and all these like tube. But it's only one single tube, right? That hasn't changed. So what is mechanical processing? And mechanical processing is actually mechanically, which is beginning at the level of your mouth. So which is the actually crushing by the tooth or your teeth, right? To propel, as well as making the material easier to digest, and then the actual propagation of the material once you swallow it. And that is the process of the peristalsis, correct? We also have digestion, which is again chemical breakdown of the stuff, as well as absorption at the level of the epithelium. So if you have a shorter small intestine or large intestine, the absorptive surface will be decreased. You're not going to absorb as much nutrients as you need. You will age sooner, right? You will have less calories in your bloodstream, means that you're going to lose a lot of weight, okay? And that happens to anybody, not only because they have a short intestines, but because they have any damage of the mucosa itself. So Crohn's disease, ulcerative colitis, anything that affects your intestines or your stomach is going to lead into something like this, right? Affection of the absorbed materials, and losing weight and losing elasticity of your skin, making you look elderly a lot faster. So the next one is secretion. You're actually secreting a couple things, and the first thing that you secrete is going to be what? Water. Where? Salivary glands secrete water, right? A lot of that saliva is made out of water. Saliva is actually a hypotonic solution, which mainly contains amylase, and that is the primary enzyme there. You also have the acid. So acid in the stomach. The stomach acid is actually mainly made out of hydrochloric acid, HCl. And that acid is about really acidic, right? So it's a low pH, and that pH is somewhere around what? Around 1, right? So you also have a couple of enzymes, right? Pepsinogen, you got activation of pepsinogen to pepsin, you have bicarbonate, you have multiple enzymes that deal with that breaking down, the chemical breakdown of that bolus of food that you just ingested. You also have buffers, and buffers mainly work by maintaining the pH. So your stomach is capable of dealing with a pH that is low as 1. That's really acidic. But your intestines, like your duodenum, jejunum, and ileum, they're not made for this. So if you release amount of whatever is made in the stomach, and by the way, whenever you swallow the food, right, you're swallowing what? A bolus of food. Why? Because it's a bolus that you just made in your mouth. You chew, you decrease the particle size, you mix it with the saliva, you start breaking down the sugars, and you put it all the way inside your esophagus, then it moves through peristalsis all the way through the cardiac sphincter, right? So at the level of the cardiac sphincter, then that bolus of food enters the stomach, right, to a process known as peristalsis. Once the food enters the stomach, then the stomach says, okay, there's something in here, what should I do? Let me start releasing what? Acids and enzymes to start breaking down whatever particles of food are in there. What do we eat? Your carbohydrates, your proteins, and your lipids. And that's what you're breaking down there. Once you start breaking that process by chemically and by mechanically, because your stomach, if you felt this, sometimes your stomach moves, right? And you get that growling, which is right? So there is a mechanical process as well, and it's mixing all the food. Imagine a washing machine, right? You're putting the content, which is the chemical, right? The soap and everything in there, and then the actual thing spinning. So your muscles in the stomach, they don't spin, but like it makes some sort of like a mixture. So once you mix that up, you don't have a bolus anymore. You have something known as chyme, okay? So that chyme is that mixture, which is mostly like a liquid, kind of like a gooey, greeny stuff, right? And then that gooey stuff now is the particles that you just ate in really tiny, small amounts. Now, that amount of chyme is going to be released now out of the stomach into the duodenum. Everybody following? So, are you going to release, I don't know, a whole pound of food that you just ate into your duodenum? No, because if you release everything at once, your duodenum is not going to be able to absorb it. So you release little by little. Who allows for this release to happen? Your pyloric sphincter. So the pyloric sphincter opens, a little bit comes out, like let's say for example 10 cc's or 5 cc's, and then it closes. And then it gives sufficient time for the duodenum and the small intestine to start processing the stuff. Once it passes to the duodenum, then the pyloric sphincter opens again, and a little more comes out. Everybody got that? But when that content of chyme comes out, that content is really what? Acidic. So if it's acidic, and you're gonna keep that amount of acid in the duodenum, what do you think is gonna happen to the duodenum wall? To the intestine? What are you gonna do? If you drink Clorox, what is gonna happen to your esophagus? You're going to damage it. Damage it means what? You're gonna create a process of an inflammatory process in there, right? So this is known as what? Ulcers. If you have a lot of acid coming out, you may end up having duodenal ulcers. Well, actually, you always heard about gastric ulcers, right? So ulcers is just irritation, right, of the wall of your stomach. If you keep pouring that acid into the duodenum without putting sufficient amount of buffers, then what's going to happen is that this ulcer will become what? Eroding. Like when you erode a wall and keep eroding the wall, it gets to a point that you create a hole. So that erosion and that wall broke through or break, right, is known as a perforated ulcer. Whenever the ulcer is perforated, imagine having a perforated ulcer in your stomach. That means that now the stomach acid and those stomach enzymes are now dumping that content into your abdominal cavity. And then at the level of the abdominal cavity, guess what's going to happen? You're going to start digesting what? Your intestines. Because your intestines, right, your omentums are made of what? Proteins and fats, mainly, right? And carbs, because the cell walls are made of phospholipid bilayer, right? So phosphates, lipids, right? The receptors on the cells, some of them are made of carbohydrates. So you're going to start breaking down your tissues. This is actually an emergency situation, right? Correct? And that's what is happening. That's why you need that buffer in there, just to lower the pH so you can still keep absorbing things. And the other thing about the buffer is that the buffers require for these guys to work. So what are actually salts, right? Salts by epithelium, digestive tract, glands of organs. So there's something that is required to be, they call it salts, but the main point here is bile salts. What are bile salts? Bile salts is just more than what? Your bile. Who makes bile? Your liver, right? Who stores the bile and concentrates the bile? Your gallbladder. So when bile comes off, and it goes off where? At what portion of the small intestine? Duodenum, right? Second portion. It was on the test. At what level? Major duodenal papilla. What sphincter? Sphincter of Oddi. Okay? What enzyme? CCK. We're going to talk about these things. So if bile now is released at the duodenum, then bile is able to do what? What is the whole purpose of having bile? to emulsify the fat. What is emulsification of the fat? It's not more than breaking down the fat, being able to absorb the fat into our body so we can use now the fat as what? As an energy, right? Okay. So that's the process of bile. So you require buffers because the bile will not work, you will degenerate it. Think about it. If your pH is really low at any part of your body, will the enzymes work properly? If you're in an acidic environment, you as an individual, if you go inside a pool and that pool, they put a lot of Clorox in it, and that pool, they put a lot of acid as well in it, what's gonna happen? Your eyes are gonna burn, right? You're gonna get out of the pool and you're never gonna come back again. Because even your skin gets really itchy. The same thing happens. Your enzymes will be denatured as you are denaturing your, the sclera of the eye or your skin. So enzymes don't work at a really low pH. Not all of them. Some of them do, but not all of them. So there is a process of absorption. And again, for absorption, where are we absorbing? Whatever we ingest, right? Your carbs, your lipids, your electrolytes, your vitamins, right? The water, okay? As well as other things that goes with the food, right? Other things like what? Like bacteria. Whether you like it or not, every time you ingest something, that food is contaminated, right? It's a minor contamination, but there is contamination of bacteria and viruses that you put in your mouth. And that, the main route that you have, or the main preventive portion is the first one that you encounter will be your mouth and the tonsils around it. Then once you swallow the food, the next level of control will be your stomach. So in your stomach, you have that acid of the stomach that's gonna break down pretty much everything. Hopefully not a lot of bacteria can go through. There's only one bacteria that allows to survive the stomach acid, and that is known as H. pylori. You guys ever heard of H. pylori? Or Helicobacter pylori? Okay? So excretion. Once you absorb all these proteins, all these lipids, all this water, all these nutrients, then whatever you have in excess, you will do what? Get it out, right? You get it out two ways, right? And we're talking about digestive, so that's making fecal matter, right? And that waste product is just gonna come out. Now, on the waste product of the fecal matter, again, is waste. Either whatever you don't use or whatever you used already, but it's an excess. Like most of the times, toxins, right? That is in there and is taken back where it's dumped into your digestive system, in this case, your large intestine. So, that's an overall of what is happening of your whole digestive system, right? That's a summary of what we're gonna talk about. So the next event is we're gonna talk about the components, right? So components are actually made of two. One is the digestive tract and two is the accessory organs. So the digestive tract is the tube, right? The alimentary canal, which is all the ones here listed here. This is your alimentary canal. Now, on the other hand, which is number two, these are your accessory organs. Why are they accessory? Because they help you propel the food, mix the food, break down the food, right? So, your body, right, made what? Teeth. You develop a what? Tongue, salivary glands, liver, gallbladder, and pancreas. All these allow for chemical breakdown, right? And biological breakdown of these structures, right? Imagine a life without teeth. You have to eat puree. Correct? Because you cannot break down any big particle. Imagine a life without tongue. Well, if you won't be able to speak, but hopefully you understand that without the tongue, or at least the back of the tongue, the root of the tongue, you won't be able to swallow. Right? You can't swallow. Try to swallow without moving the back of the tongue. Go. Swallow some saliva. See if you can. You cannot. It's weird. You choke to death. Try it. If you're able to do it, I'm going to film it. All right? So there is a process there. Life without tongue means you have all taste receptors on the tongue. So imagine a life, adult, that would be adult life, right? Salivary glands. A life without saliva, that means you have to mix your food all the time with water. Okay? Liver. A life without liver. Liver is the one that processes pretty much everything. Is detoxifying main organ in your body. Is the one that produces bile. Okay? A gallbladder as well. The pancreas as well. I'm not going to go into a lot of details because I can talk here for a month just about those things. So this is a picture about the majority of the structures and accessories as well that we have. You are responsible for all these, right? So little by little, you're gonna go over these. So the first one is the oral cavity, right? You have your teeth, you have your tongue in there. Then again, like we said before, the food goes into the esophagus, then it goes into the stomach when you have this enzymatic activity, acids, right? There is a mechanical breakdown of stuff. So mechanical processing through the muscular and contractions of the stomach. Then food goes into the duodenum, right? And then you have another accessory, which is your pancreas. And your pancreas creates or secretes buffers and digestive enzymes, right? Which are going to secrete some hormones and help you absorb the food. From there, it goes and move to the small intestine. Once you go into the small intestine, you have, again, another enzymatic, water, organic substrate, vitamins, and ions are going to be absorbed in here. Once all that happens, then the food goes into the large intestine. And the large intestine is the second part that your food gets dehydrated. And at the level of the cecum is where you start creating fecal matter, like truly fecal matter, what it looks like. Okay? So this just making the final preparation for elimination, which ends up at the level of the anus. Right? So that's pretty much the overview. Now, in your abdominal cavity, that's where you find almost all these structures. So in that abdominal cavity, your organs are actually attached and protected. So attaching wise, you have in the liver, you have the falciform ligaments, right? The liver is actually attached to the transverse mesocolon. I'm sorry, to the transverse colon through something known as a what? The lesser omentum right here, right? Let me erase all these things. So it's attached through the lesser omentum. You also have another omentum which is known as the greater omentum. And this omentum is not more than something known as mesentery. So mesentery means what? Mesentery is a double layer of your peritoneum. What peritoneum? You had a parietal and visceral pericardium, right? You have a parietal pleura and a visceral pleura. You have the same thing here. Visceral peritoneum and parietal peritoneum. So a double layer of it is what makes up the omentums. And again, you have three of them. Lesser, transverse mesocolon, and greater omentum. These omentums, they have inside of them, they have lymphatic vessels and lymph nodes. And they prevent from infective organisms or any infection to enter and infect your intestines. That's something that you want to take care of, really good take care of it. Because if you don't absorb the food, then your body cannot work. It doesn't have any way of getting food from anybody, from anywhere, right? So it provides as well padding, protection because of the lymphatics, right? And protection as well if you have a individual that has increased amount of greater peritoneum. So obese individuals or people that tend to have big belly, and you can have a 6-pack, you can have an 8-pack, and your belly is like this, right? You've seen that, especially bodybuilders, right? When they take growth hormone, some of them, they develop this big belly, but they're all, ripped. So subcutaneous way, they have no fat at all, right? You can see everything in there, every single muscle, but their bellies are big. Now, that doesn't mean that they don't have any fat. The fat that gets accumulated on the abdomen, it can be in two places. Either underneath the skin, which is the area one that they don't like because it looks bad, and nobody pays attention on the fat underneath. What's the fat underneath? The fat underneath is the what? The greater omentum. So you start building fat in there, and then that's genetic predisposition, right, to some of us. But you start building that fat on the inside of your body, and that fat is the greater omentum. You'd be like, but that we need that. Yeah, you need that, but you don't need that much. Because if you have a lot of fat on the greater omentum, what is that going to do to your intestines? That is going to do what? That is going to press on all your intestines if you keep building fat in there. So it's like you're being pregnant, right? So it's going to push in your intestines and having less capacity inside the body. So that's another way of storing fat. You don't actually have to do it on the subcutaneous, but you can do it on your belly underneath. Okay? Now, the alimentary canal, right? Again, it's a single tube, goes to the mouth all the way to the anus. Where does digestion begins and where does digestion ends? Digestion begins at the level of the mouth. With what? With an enzyme known as amylase. Amylase is the enzyme that breaks down your simple sugars. Can anybody tell me simple sugars? Fructose? Glucose? Sucrose, no. Sucrose is your fructose and glucose. Okay, galactose. So those are your monosaccharides. At that level, if you ingest any of those monosaccharides, as soon as you put that in your mouth and the saliva start mixing, you're going to start absorbing what? Sugars. So monosaccharides are absorbed at the level of the mouth. If you absorb disaccharides or polysaccharides, they get absorbed all the way through. You have different places in your body that you release amylase. So that absorptive surface, right, is provided by who? Let me erase everything so that way it makes sense when I do it. So that absorptive surface and secreting surface is at the level of the mucosa. If you damage the mucosa, would you be able to secrete the fluid? Would you be able to absorb it? No, you won't be able to. Or if you do, it's going to be decreased exponentially, right? Now, you keep absorbing food all the way through your rectum. So digestion starts at the level of the mouth and ends at the level of your anus or the rectum. So far so good? You're still absorbing things, you're still metabolizing things. Okay. So in the mucosa, we call that there's epithelium, right? Is the tissue. So that mucosa is made out of a stratified squamous epithelium on the oral cavity and your pharynx and the esophagus, right? Your mouth all the way to your esophagus. The simple columnar is starting where? Stomach. So it's really simple, right? You have the stratified squamous epithelium from your mouth all the way to your esophagus. At the level of the stomach, you start with a new one, which is what? Simple columnar. Now, there's the next layer, and that layer is known as the submucosa. And again, I'm just covering the main layers, right? The submucosa, if this was the mucosa, underneath is sub, right? Like subway underneath the way. That's where the name came from, I believe, right? So sub is actually underneath. So submucosa is underneath the mucosa, and that one has this. And that is known as a Meissner plexus. What is the Meissner plexus? Is part of your autonomic system. What is your autonomic system? Can you control autonomic system? No, right? Not normally, you should not. So that autonomic system is the one who's going to have the sense the electrical impulse to regulate, right, the impulse of peristalsis, right? The muscle contraction and relaxation, which is known as peristalsis. Then you're going to have the muscularis externa. The muscularis externa, you have a mesenteric plexus or our back plexus. This plexus is the actual one that has the muscle. The muscle that does what? Constriction and relaxation. And that process is the process that is going to propel the food down our alimentary canal. And that is known as peristalsis. Okay? So again, this process of absorbing food and peristalsis is going to be regulated by two systems, right? One is going to be autonomic system, and the other one is going to be what? So 1 and 2 right here on the bottom. So it's going to be regulated by parasympathetic and sympathetic. Remember, your autonomic nervous system is divided into what? Sympathetic and parasympathetic. When you are in parasympathetic, means what? You rest or digest. That means you are digesting the food. That process will increase. You have elevated peristalsis. All right? Now, if you are in sympathetic state, that means you're fight or flight. Are you worried about being hungry when you're fight or flight? No. Do you care about digestion? No. So when you are in sympathetic mode, let's say you ate food, and whenever you're in sympathetic mode, what's going to happen to your peristalsis? Your peristalsis will be delayed. The absorption of food will be delayed. So if you're really stressed and you put the food in your mouth, you just swallow the food, right? You actually end up feeling what? Kind of bad, right? You like a bolus of food or like a ball in your intestines, right? You feel like you're not digesting it. That's because you are in sympathetic state, okay? Because at that moment, your body's not absorbing anything. It's just making sure that you stay what? Alive, okay? So, and finally, the outermost, which is your serosa, okay? That's the outermost layer. So, the next event, we're actually going to be talking about the small intestine, right? So, within the mucosal layer, and then we have different characteristics or different shapes of the mucosal layer. So as you go from the mouth to your esophagus, we said that it was what? Stratified squamous. And whenever you move from there to the stomach, what do we have? Simple columnar. As the columnar epithelium comes on and off in kind of like waveforms, it creates something like this. Right? In the stomach, what do we create? These are known as what? Rugae, right? This creates rugae, right? In that rugae, right, that's where you have your villi and your microvilli, right? But mainly, that microvilli and microvilli is not on the stomach at all. It's most likely where? On the small intestine. So if your small intestine, it creates this some sort of lining. Remember what these are? That is in the actual lumen of the small intestine. Plica circularis. So this shape of mucosa creates another structure known as plica circularis, right? And that shape keeps changing when you go from the mouth, stomach, small intestine, and large intestine. So in your small intestine, why do we care a lot about that plica circularis and the mucosa? Because in the small intestine, you have different parts of it. So what are the different parts of the small intestine? It's divided into three main parts, right? One is going to be D, J, and I. I am the DJ. That's how I remember it. So D is for what? Duodenum, right? J for what? Jejunum, and I is for what? Ileum. So what parts of my small intestines are going to do what? So in the duodenum, you're going to have a lot of these glands, which are known as Brugge's glands. These glands are on the submucosa. Remember, you have the mucosa and then underneath, submucosa. These guys are the ones that are going to allow me to create something known as crypts of Leverkon. Okay? Why is that so important? Because at the level of the duodenum, what are the parts or things that I'm going to be absorbing? I'm going to be absorbing what? Iron, copper, correct? So most of the iron and copper that is absorbed in your body is at the level of the duodenum. Why do I care about iron? Because iron is the basis of what? Heme, right? Of hemoglobin, right? Which is the basis of my what? Red blood cells. Without it, then I do not have what? Ways of transporting oxygen, right? Or no red blood cells. So, J, the next one is your jejunum. In the jejunum, what is there? Well, the most common type of cells that you have are known as goblet cells. So if you ever see a question that says goblet cells, that is most likely at the jejunum. So the question will be, does that mean that I don't have any other goblet cells anywhere else? No, you do have goblet cells all the way throughout your small intestine. It's just that at that level is where you have the most. So goblet cells. In this portion of the jejunum, or this portion of the small intestine at the jejunum, you're going to absorb a lot of what? Folic acid, lipids, absorption. That's where it does what? Starts. So the question could be, what part of your small intestine is the one that is in charge of absorbing lipids? Jejunum and ileum. Starts where? At the jejunum. Does that make sense? So if you have a patient who has a problem at the level of the jejunum, if they cut the jejunum, or if they have ulcer at the jejunum, or if they have polyps, or whatever it is that they have, damage of the jejunum, what is the deficiency of your patient? Your patient will have deficiency in absorbing folic acid and lipids. Does that make sense? And that's where you're learning these things. If you have a deficiency of folic acid, you have to understand if you are a woman, right, you need folic acid for what? For pregnancy. If you are male or women, you need folic acid to make what? Red blood cells. Remember, red blood cells require iron, amino acids, folic acid, and vitamin B12. All right? So that's required for making hemoglobin. Now, the I, which is the ileum. In the ileum, you have a lot of what? Paired patches. That is the structure, right? Paired patches. We talked about paired patches. Do you remember what was about paired patches? Paired patches were part of what system? Lymphatic system, right? So the spare patches are part of your MOT, mucosa associating lymphoid tissue. And what is released at the level of the spare patches? IgA. So immunoglobulin A. So guess what? Every time you have a bacteria, every time you have an infective agent or pathogen that's trying to invade, you don't only have the stomach acid, but you also have immunoglobulin A being released in your small intestine. Isn't that great? Right? So it prevents from any superinfection or superpopulation. So at this level of the ileum, you have calcium absorption, right? So imagine a life without calcium. No bones, no muscle contraction. So any individual who have a problem or damage on the ileum, they can name whatever they want, right? An ulcer, irritation, inflammation of the ileum, a polyp, a mass, whatever, a cancer, whatever. That means that they are going to be deficient of what? Calcium absorption. Right? That means they will not be able to contract their muscles, right? They will have bradycardia, right? And they may end up having spasms as well. Now, the other thing is DECA. What is DECA? DECA, these are vitamins. So you have two types of vitamins, and we're going in now into a little bit of what? Nutrition. So vitamins can be water soluble or lipid soluble. If the vitamins are water soluble, the way I learn it is that I see them. So I say CB. CB because I see it in the urine. Because if it's water soluble, if I drink too much of it or I take too much of the vitamin, they're going to end up being my P. Again, in the United States, we have the most expensive P because we take supplements pretty much for everything, whether we need it or not. So C, vitamin C, and vitamin B, whatever, B1, B2, B3, B16, B12, right? You get the point. So that CB is going to be water soluble. Now, we said that the jejunum and ileum, what do? Lipid absorption. So what vitamins are DECA? These are lipid based. So they're water soluble and lipid soluble. So the lipid soluble is vitamin D, E, K, and A, DECA. So if you have any damage on the ileum, most likely you will have a deficiency of vitamin what? D, E, K, A. Okay, where do you get vitamin D from? Sun. So if you go to the doctor, and almost everybody that goes to the doctor, I do not understand why, right? That would be a good research, investigative research. Most people that go to the doctor, from sometimes you live in Miami, why are you deficient on vitamin D? Because you don't take sunlight? Really? In Miami? I mean, unless you actually have what? You put sunscreen every single day, 15 minutes before, and your car's a really dark tint, right? And you get out with an umbrella. You should have plenty of vitamin D. The other thing is like, why is your body not producing or absorbing vitamin D? It could be because you're not have good intake of vitamin D, right? Because you are eating something in your intestines that is preventing vitamin D from being absorbed. Or you're eating the wrong amount of lipids or the wrong type of lipids that is not absorbing vitamin D, right? So anyway, let's keep going. Intrinsic factors. So we talk about intrinsic factor, and intrinsic factor was made by the stomach and is required for the absorption of vitamin B12. Remember we talked about that. Vitamin B12 is a water-soluble vitamin, but intrinsic factor is not, and is needed to be absorbed in the ileum. So any individuals who have a resection of the ileum or any damage of the ileum, they will end up having what type of anemia? This question was already asked. What type of anemia if they have a problem with the ileum and vitamin B12? Pernicious anemia, which is also known as megaloblastic anemia. So that is a question that you're going to see in your exam, because this is truly application. Okay? So pernicious or megaloblastic anemia. Okay? That's right. So, going back, have you ever heard of celiac disease? So celiac disease is also known as celiac sprue. And celiac sprue or celiac disease, these are individuals that have to eat anything that is free of gluten. Why? Because every time gluten touches the mucosa, it creates an inflammatory response. That means your body is allergic to gluten. So you make an antibody or you make an allergic response to gluten, so the mucosa gets inflamed and you actually feel bloated and you don't absorb foods, right? And there's a whole series of side effects that happens with that. So that's why you can only eat wheat, barley, and rice, right? But there's free of gluten. And a lot of people are moving out of gluten because it's been known to gluten to cause what? Inflammatory process. So if you eat a lot of food that has a lot of gluten, right? And you feel bloated some of the times or most of the time after you eat a big chunk of gluten, right? Or a big chunk of cereal or something like that, that means your body is trying to tell you something, right? Sometimes you eat food and that food doesn't sit well on you. Maybe because of the time, but if you eat the food and it doesn't feel good on you, what are you supposed to do? Ignore your body? No, your body's telling you something, so you gotta stop the food, right? For a little while and try it again. If you keep doing the same thing, then try to stay away from the food. So the next one is gonna be the tropical sprue. And tropical sprue is similar to celiac sprue. The difference is that this is caused by a bacterial infection. Let's say you ate something out of, I don't know, one of those food trucks that we have now, which is really common, right? In Latin America, we don't got food trucks. We have a lot of like riggy dingy things, right, on the porches of the houses. They put a stove and they cook something and you eat it. It's a really bargain, right? It's a good price. Same thing with food trucks, right? Not much, they're pretty expensive anyway. Some food trucks here, like, they're weird, right? But anyway, so if they don't cook the food correctly and there is any bacteria, which there is, right? You get that bacteria and infects your ileum, you may develop something as celiac sprue. The only difference is that this one you can treat it with antibiotics. This one, the celiac sprue, you can treat it because it's autoimmune. So far, so good?
When you have food poison, is it kind of the same thing?
No, food poisoning is because a bacteria that you ingested, and most likely that's caused by Staphylococcus. Right. There's one that is SSS, is a triple S. So Staphylococcus aureus supertoxin. And actually, once you ingest the food, you automatically start vomiting and having diarrhea, like within an hour or 30 minutes. So it's most commonly seen in, you're gonna talk about this in microbiology, right? That's one of the things that hopefully your microbiologist professor is able to give you the application of the microbes on the actual world and how does it affect you as an individual and hopefully your patients. So, but yeah, that's by Staphylococcus. All right, so we talked about the small intestine, movement adjusted material. So, how do we move stuff around? Well, we said that already is done by something known as peristalsis, right? And that peristalsis requires two things, right? The mesenteric plexus or our back plexus, right? And it also requires what other? Submucosa, which has the mesenteric plexus, correct? So those two guys are going to provide for, one is the nerve impulses, the submucosa, and the other is going to be the muscular contraction on the muscularis externa. Both of them together, right, are going to allow you to do what? Or to create some sort of what? Waves of contraction, which is known as what? Peristalsis. So peristalsis occurs in pretty much all your digestive tract, and there's a little difference here on the part that says segmentation. The place that you have segmentation is most likely when you are at the level of your large intestine. Remember, the large intestine, you have different segments of the large intestine, right? You have these segments are known as house truths, right, or haustrum. So that's where segmentation actually takes place. So again, peristalsis is the movement of food, right, from the mouth all the way to the anus, right? And there is, of course, a wave of contraction of smooth muscle that allows for this to happen. So how do your body controls that movement of food or that peristalsis? It's controlled by your autonomic nervous system. It says autonomic, right? Automatic. And it's a little bit of sympathetic and parasympathetic of it, right? So apart from that nervous system, you have other things known as what? Local factors. What are local factors? If you have food that is entering your stomach, then that's a local factor. If you have food in your esophagus, then that's a local factor. Does that make sense? Now, neuronal mechanism. Again, autonomic nervous system is neurons, right? So that neuronal mechanism can be either through a short reflex or a long reflex. Again, this is still autonomic nervous system, right? Sympathetic, parasympathetic. what is a short reflex? A short reflex is a reflex that occurs within the area. So if you have food in the stomach, the short reflex will be the stomach moving to mix the bolus of food. A long reflex of the stomach, right, of the neuronal mechanism is like you looking at a food that is so beautiful that you just want to taste it. And as well, you're smelling the food and it's so smelly, right? So good that you're able to do what? Drool. You drool. If you are hungry and you smell food and you look at a food that looks and smells pleasing, then most likely you are going to desire the food and you will be hungry, right? So at that moment, your stomach starts secreting what? Acids. And that acidity and your stomach starts moving. It's like growling on you, like, I wasn't hungry a minute ago. And I saw this commercial of Starbucks or McDonald's or whatever, and you saw look at the food and you're like, all of a sudden, right? And that's what they're trying to do, right? They're trying to stimulate your nervous system, right? The long reflex. So, again, local factors, right, is the food entering and causing all these things to be released. Prostaglandin, histamine, other chemicals according to the area. The neuronal mechanism, again, is you have a short reflex, which is outside the CNS. What is outside means on the actual local organ, right, around the organ. And then a long reflex will be basically coming from the nervous system, right, which secretion of acids and movement of the stomach and peristalsis.